All right, so this is week 4, and this week I originally had like Affine and Visionary set up, but I just thought that would be a little much to like process in 1 hour. So I set Visionary for next week, and this week we're doing Affine. And yeah, this is what I was talking about. Visionary is next week, and then after that, you can see what we're doing. It's mostly, one cipher per week. Pollux and Morbit are just grouped together because they're just variants on Morse code. So like they operate by almost the same exact rules. This is just a copy and pasted slide from last week. It's just like basically make sure you know what you're doing with letters and numbers. That's all. Okay, so like before we get into the actual like encoding and decoding of Affine, there's like two basic things we need to build off of. So there's letter number conversions, which I put like we're good at this now, hopefully. We don't have to be that great at it yet. We're still going to be working on this like throughout the class, right? So as long as we like chose those anchor points in our head and we can like count from there, then we'll be fine. And modular arithmetic, I don't remember learning this in school, like in middle school or anything. I just remember like learning it somehow, but I don't think it was in the school curriculum, so I just included like a couple of slides going over it. Uh, okay. I didn't make a poll, but if you guys want to like direct message me through Zoom if you've like learned about it or not, that would be good. Okay, yeah. I'm seeing mostly responses that you haven't learned it. So I'll make sure I go over it a little bit slower, more in depth today. All right, so this first slide is on modular arithmetic. Modular or modulo is usually just shortened to mod when we talk about it. So like in the first sentence, you can say that you can see that I said taking x mod y. So that means x modulo y. The modular operator, I think that's what it's supposed to be called. It basically means take the remainder of. So if I have x on the left side of the mod and y on the right side of the mod, it means take x, divide it by y, and tell me what the remainder is. That's all it is. So you take what's on the left side of the mod, divide it by what's on the right side of the mod, and then tell me the remainder. So that's what modulo means. So for example, 5 divided by 4, if you want to think about it this way, it's 4 and 1/4, or okay, I'm being stupid. It's 1 and 1/4, right? So then your remainder is 1 because you have 4 plus 1 equals 5. 5 divides exactly into 10 because 5 times 2 is 10. So your remainder is 0. So you'd say 10 mod 5 is 0. And then if you do 12 times 3, you get 36. So 42 minus 36 is 6, which is your remainder. I just did it by like subtraction, but it's the same thing. So when we're doing math in Codebusters, the mod, aka like the y or what's on the right of the mod operator, is always going to be 26. Because remember how I said like we have to think about the alphabet as like a circle and it like repeats itself in Codebusters? There's 26 different, like, if you imagine it as a clock, there's 26 different hours in the day. So once we complete one cycle, we need to refresh our hours. So that's why we take everything mod 26. Yeah, but once again, A is still 0. It's not 1 through 26, it's 0 through 25. And there's one more thing for like modular arithmetic that we kind of need to cover. It's like the concept of inverses. So you've probably like heard before that multiplication is the inverse operation of division. It basically means like if you do A times 1 over B, it's the same as doing A divided by B, right? So that's the concept of inverses. In modular arithmetic, 2 inverses will multiply to equal 1 mod whatever you choose. And remember, like we just said, we're only doing mod 26 in Codebusters. So 1 mod 26. So if we just like, I have this table at the bottom that you guys can see. If we just run through a couple of them, like okay, hold on. 1 times 1 is 1, right? So obviously, if you divide 1 by 26, your remainder is 1 because you multiply 1 0 times into 26, and then you have 1 left over. 3 times 9 is 27, and if you do 27 divided by 26, you get a remainder of 1. And you can like check all of them if you really want to make sure that they're correct, but I promise you that the table's correct. Okay, so this is like getting into actually doing the cipher. So Affine is built on the concept that like you have this linear equation y equals ax plus b. You might have learned it as like y equals mx plus b in school because like m is like a shortened French word for slope or something. I forget exactly. But in this case, we're just going to substitute the m for an a, and it doesn't matter what they are because they're just both variables. So basically, in encryption questions, and we're learning encryption first because it's easier to understand like how to decrypt if you just think about it as the reverse of encrypting. Yeah, so back to what they'll give you in the prompt. They'll tell you A and B. And, you know, if you don't know that this is based on a linear equation, obviously, like that does not mean anything to you. But if you think about it as y equals ax plus b, they're telling you the coefficient of x, which is a, and then they're telling you like the y-intercept of the line, right, which is b. I say y-intercept, but you're not going to have to like graph anything. So basically, what a equals 5 and b equals 13 means for our purposes is that they're telling you to encrypt with the equation y equals 5x plus 13. That's all it's saying. And so the question becomes like, what is x and what is y? Like, what do those mean in this case? Basically, x, if we think back to like the terminology that we learned a long time ago, x is our plain text. So that's the message that we want to send. So if I want to send hello, actually that might be on the next slide, but if I want to send hello and I'm just focusing on the first H, because you have to encrypt letter by letter, you can't really go word by word or anything. You have to do single letters each time. If I want to encrypt H, the first thing I have to do is I have to think about what number does H correspond to if I just like convert from letters to numbers. And I don't know, maybe you count 1 backwards from I to get H is 7. So I have x equals 7 because H is my plain text. And then I plug that in. Oh, I should add that this is all mod 26. So if you get 5x plus 13 is something like bigger than 26, like say it's 1 million or something, you have to divide it by 26 and find the remainder. So, okay, back to what I was saying. We have y equals 5 times 7 plus 13 mod 26. That's 48. So 35 plus 13 equals 48. And then 48 is 22 more than 26. So then our remainder, remember we're looking at the remainder because of the mod function. Our remainder is going to be 22. So y is going to be 22. And like how I said, x corresponds to the plain text, y is your ciphertext. So if I wanted to tell somebody H, like for no reason, and I want to encrypt that because I don't want anybody else to know that I'm saying H to this person, and I use this y equals 5x plus 13, I would tell the person Y, and or not Y, 22 is W. So I would tell the person W, and then the person would decrypt my W into an H. All right. I think I might have just done the next slide already, but we'll see. Yeah, so I'll just continue with this theme since I only covered the H. But basically, you can see how I got to the H. And now, like, if we look at the E, I'm just doing the same thing again. So I have y equals 5x plus 13. I'm not going to write the mod 26 because it's just understood, right? Because you can't convert this back to a letter unless it's under 26 or greater than or equal to 0. So this time it's y equals 5 times 4 plus 13. 4 is from the fact that E converts to 4. So this goes to 33. And then that's too big because it's not 0 to 25. So we have to do divide it by 26 and find the remainder. If your numbers are small enough, really what you can do is just minus 26 because that achieves the same thing. Because you're essentially doing 26 times 1 and then finding the remainder. So minus 26 equals 7. So E goes to H because 7 is H. So yeah, as you can see, we have W, H. And then here you have repeated L's. So since we're applying the same equation to both of the L's, their Y's are going to be the same. Because if you plug in the same X, you know, to the same equation, you can't have different Y's. The numbers can't get really big. Because if can't as in like cannot. Because if you think about like how you would make the numbers big, you would have to plug in like x equals 25, right? That's the biggest x you can plug in because that's C and that's like our upper limit. And even x equals 25 like can't get huge. Because like if I just do mental math, that's 138, but that mod 26 is like 8. And that's only like 26 times 5. And then a remainder. Like if that makes sense, like 26 times 5 is 130, and then the remainder would be 138 minus 130, which is 8. So it can really never get any bigger than like 25 times 25 plus 25, which still isn't that big of a number. Yeah. Okay, so yeah. So what I was saying is that you only have to do like plugging in 11 for L once into the equation because every other L is just going to be the same exact output. So y equals 5 times 11 plus 13, 68. 52 is a multiple of 26. So what I like to do instead of like on my calculator dividing and then like using decimals to find the remainder and stuff, I just like to think about the closest remainder, or not remainder, the closest multiple in my head and subtract that multiple. So 52 is just 26 times 2. And then we can see that the remainder is 16, which goes to Q. And that's why we have two Q's that substitute the two L's. And then lastly, I'll just do O2. 5 times 14 plus 13, 70, 83. Okay. And then if we do minus 78, yeah, I think that's right. That's 5, because 78 is 26 times 3. So 5 goes to F, so that's why we have F. And that's all there is to encryption. It's just make sure you know how to convert letters to numbers. You really don't even have to know modular inverses for this. For encryption, you definitely do have to know them for decryption. But for encryption, it's just letters to numbers, know how to substitute into an equation, and know how to find the remainder. That's all. Okay, so now we have an example for encryption. One thing that's always easy to start off with is A. Or actually, first, probably just tell me in the chat what A equals 7 and B equals 10 means. Like, how would I form that into an equation? Why is that important to me? Yeah. All right, so y equals ax plus b, and then we substitute a and b to see that y equals 7x plus 10. Okay, so like I was saying, what you probably want to do first in encrypting Affine is you want to look for A's to encrypt because number one, remember that A's are super common. They're the third most common letter in English because ETA. And then A goes to 0, like it's converts to 0. So that makes substituting in 0 for x really easy because if we have a 0 for x, this 7x is also equal to 0. So all we have is y equals 10. So anytime you're encrypting A, you just put in, thanks, A equals K. Okay, I said it was common, but I guess there's only 3 in this quote. And usually what I like to do is if you like jump around, like say I do U and then do H and then do N, sometimes you can like end up filling the wrong stuff in the wrong place. So I like to just go left to right. But but like left to right with a bit of I guess exceptions. Like if I do L, I don't want to just redo L in the next step because I'm going left to right. Like the first time I do L, like I just did with A, I want to look for all of the other L's in the same quote and then fill them in and then do the next, like basically, and then do the letter that came after L, which in this case would be T because we had an L here. Okay, so if we do L, okay, I'm not going to show work for this one. Can somebody just tell me what L goes to? And I'll just have the answer ready just in case I need to check. And if you're not sure about like the letter conversion, you can just tell me the number too. Here, I'm just going to write this mod 26. Yeah, it's J because 9 goes to J. So all the L's get filled in with J's. And that's only 2. Okay, so I mean, basically, I think you guys get the gist of it, but we're just going to finish this one out. Just so you can see like that the numbers actually don't get that big, because even when we're plugging in t equals 19 in for x, it doesn't get that huge because that's 70, 63, 133, 143. So 143 mod 26, I think that's 13. Because 130 is 26 times 5, and then 143 minus 130 is 13. So that means all the t's goes to n's because n is 13. All right. I'm going to be working like left to right. So if anybody wants to work right to left and just tell me like what maps to what, like Ethan just did for A to K, that would be helpful. $59, $52, 7. H goes to H. Oh, yeah. One thing I didn't say is that a letter can go to itself in Affine and visionary. The only ciphers it can't go to itself in are aristocrats, patristocrats, and xenocrypts, the ones that I call monosubs. In anything like based in math, it can go to itself. Oh, I guess it can't go to itself in like Caesar or Apbash, but it can go to itself in anything like actually math related. G to Y. Wait, really? I think I'm getting G to A. Oh, I'll also check E to M. Yeah, E to M's right, I think. Because M is 12. I think you might want to recheck G to Y though. I'm pretty sure it's G to A, because like if I just show G is 6. So this would be 42 and this is 10, so that's 52 mod 26, and 26 times 2 is 52, so it goes in evenly, so the remainder is 0. I to O, 56, 66, 52, yeah, I to O. F to T, 5, 35, 14, yeah. Thanks. $150. Also, it generally like the reason I can do it quickly is that I have like a decent amount of multiples of 26 in my head. Like this one, I know the nearest multiple is 130, so I can just do this minus this equals 20. So, okay, U goes to itself too. 98, 108, 104, yeah. Yeah, letter number conversions are usually what slows people down the most at the beginning. But I mean, it'll come over time because we have to do them in almost every cipher, so you'll learn. Yeah, U is U. Okay, yeah, I'm just going to repeat myself again just in case people didn't hear. In anything math related that's not like Caesar or Apbash, a letter can map to itself because like math doesn't know what letters are, right? So letters can just go to themselves. But in anything like letter related, like aristocrats, patristocrats, xenocrypts, even Caesar and Apbash, it can't go to itself. S is W. 18. Oh, I'll rewrite the equation. 70, 126, 136. Hold on. I think I messed up my math. S is, I'm getting S as G. I might be doing it wrong. I'm just going to check with the calculator. Yeah, I think S is G. Because if I just show it, 7 times 18 plus 10 is equal to 136, and then 136 minus 130 is equal to 6. And the reason I'm doing minus 130 is because I know it's a multiple of 26. You meant Y is S. Okay, 24 times 7 plus 10 minus that. I think Y is W. I'll just show that again too. Oh wait, hold on. I'll do Sierra's first since it's higher in the chat. Wait, okay, yeah. N equals C or D. So 10101. Hold on. Wait, I don't think so. Because if N is 13, right? So if we plug in 13, that gets 91 plus 10, which is 101. And then, oh, sometimes you don't like happen to remember the nearest multiple of 26 that's right below it. So you might do the multiple of 26 that's right above it, which I know is 104. So that gets us -3. But then you can just add 26 on top of that and you get 23, which is X. Oh, yeah, that happens. Yeah, it happens. Hold on. This is for N. Okay. W equals I, 7, 22, 10, 140, 154, 164, 34, 26, 8. Yeah, nice. Okay, I guess we only have Y left. Y equals C. I think so. Let me just see. 148, 158, 130, 28. Yeah. All right, nice job. So that's how you encode. I mean, as long as you just, remember to include the coefficient. Maybe like, I guess writing it down could help instead of like mental mathing it. But yeah, as long as you remember the coefficient, then it's quite straightforward. Like there's not much to forget about. But in decryption, there's a little bit more to remember. So I'll get into that in the next couple of slides. So here, if I go back a couple of slides, you can see how at the top, like I have E of X. Okay, I'm just going to assume you guys like know what a function is, even though it doesn't really matter for this, but like E stands for encryption here. So like the encrypted version of X is AX plus B mod 26. But then the decrypted version of X, which is capital D, and you don't have to like actually write this notation. This is just like how I found a picture. But the decrypted version of X is the inverse of A. That's what A to the -1 means, the inverse of A, times X minus B mod 26. We're actually going to call this the decrypted version of Y because if you remember how I said that y is our ciphertext and x is our plaintext, it doesn't really make sense to decrypt our plaintext because like we already know what the plaintext is, right? So we're actually going to be decrypting y and substituting y. So here, this is just like a walkthrough of how we got from, like point A to point B. So we start with the encryption equation, and remember that this is all mod 26. We subtract b from both sides to get y minus b equals ax, and then we divide both sides by a to get x by itself. So x equals y minus b over a. But the problem is that we can't always divide. Like we can't always do something divided by a. Like I'm just going to say y minus b. We can't always do that because division doesn't always work, especially if we're doing like matrices or like modular math or something. Not that you have to know what matrices are. But this is the same thing as 1 divided by a times y minus b, which is the same thing as a to the negative 1 times y minus b. And a to the negative 1, this term is where when we talked about modular inverses, that comes in. So I pasted the table at the bottom here too. If you look like the modular inverses are written vertically. So 1 pairs with 1, 3 pairs with 9, 5 pairs with 21, and so on. And if you want to check them in their calculator, you can just multiply the two inverses together and then find the remainder of 26. All of them should have remainder 1, or their product should have remainder 1. Okay, so I don't know. I don't think you've noticed yet maybe, but there's a reason that a can only be odd numbers from 0 to 25, or even 1 to 25 would be a correct explanation. But there's a reason a can only be odd and it cannot be 13. Because if you think about it, if we need a to multiply with its inverse to give us 1 mod 26, if you divide something by 26 and it gives a remainder of 1, that something has to be an odd number because any multiple of 26 has to be even. And if you add 1 to a multiple of 26, which that's what 1 mod 26 means, it has to be an odd number. And you can't have an even a times anything and expect to get an odd number. So a has to be an odd number in order to multiply by something else to get an odd number, if that makes sense. And the reason it can't be 13, even though that's odd, is because if you have 13 multiplied by anything, like look at 13 by 1, that gives you 13, which it doesn't have an inverse because 13 is exactly half of 26. So if you multiply by any even number, you just get mod 0 because it's going to be perfectly divided into 26. And if you multiply it by any odd number, you're going to get 13 mod 26. So that's why it doesn't work as an a value. So you can have 1, 3, 5, 7, 9, 11, 15, 17, 19, 21, 23, 25 as a values, but nothing else. Okay, so yeah, let's put this to work, I guess. I guess I need to erase all that. Okay, so basically this slide is going to be like how to actually solve now that we have that, I guess, theory done. So we need to keep in mind that this is our equation. X being the plaintext, Y being the ciphertext. So plaintext equals modular inverse of A times ciphertext minus B, and that's in parentheses, mod 26. So here, this is the reverse example from the encryption. So just in our minds, we know this goes to hello, right? Because I just reversed it. And then A is still 5 and B is still 13. Yeah. So what we need to do now is we had y equals 5x plus 13. And we need to rearrange that into this form. So we have x equals, this is a, so we need to find the modular inverse of a. And if we look at the table, 5 and 21 are modular inverses. So we have 21 parentheses. Y, b value doesn't change, it's just b, so y minus 13. mod 26. Okay, so say we want to just decode this for fun, even though we already know what it decodes to. W is 22. So if I substitute in 22 for Y, 21 on the outside, 22 for Y, this is equal to 21 times 9, which is equal to 189. And this is all mod 26. I know that 182, I think, is a multiple of 26. So if you subtract, then you get 7, which is equal to H. And that's how you decrypt the rest of it too. Same thing goes for decryption as encryption, as that you have double queues here. You only want to do the math for one of the queues, and then you can fill in the rest of them throughout the cipher, because you don't want to do, extra work, because it's just going to slow you down, or open the potential for making a mistake. So you just want to do it as efficiently as possible with as little steps as possible. Okay. How many of these do we have? Okay. So I guess we'll take a look at this. Tell me what A equals 5 and B equals 11 means in terms of encryption, and then we can find what it means for decryption. Yeah, so Y equals 5x plus 11. That's what we do when we encrypt, but it says solve, which basically means decrypt or decode. All of those three things mean the same thing. So we need to rearrange this to get x equals. So, I mean, basic solving skills. I mean, you get this, right? And that doesn't look super pretty, but basically what it means is that we had that equation from before this thing. And remember that this outside coefficient just means inverse. So what we're going to do is we plug it in, x equals 5 to the -1, right? Because we're dividing by 5, so we use the inverse of 5 times y minus 11. Because like multiplying by the inverse of 5 is the same thing as dividing by 5. It's just that in this scenario, we're mod 26, so we can actually find what the inverse of 5 is. So somebody tell me what it is. Yeah, 21. So if we refine our equation a little bit, it's x equals 21 y minus 11 mod 26. And kind of used a lot of space already, but like I'll do z as an example. Or actually, if you remember how I said like you want to start with a for encryption because you just substitute in the y-intercept if it's a. For decryption, you see how b is 11 here? You want to find what y is equal to 11. So if you think about it in your head, 11 is the same as L. So you want to look for L's in the cipher, because if you do 11 minus 11 into parentheses, you get 0. 0 times anything is 0. So x is going to end up being 0. So L is going to map to A, because A is 0. So basically, you want to look for the letter that matches the B value, because then you can get what's inside the parentheses to equal 0. So L goes to 0. 11 goes to 0. And one nice thing about affines is that you can almost solve them like aristocrats. It's just that a letter can go to themselves, and like multiple letters can go to the same letter, if that makes sense. But in essence, it's just like an aristocrat with a couple exceptions to it. I have to move the chat because I can't see the top right. Okay, we don't even have that many L's, do we? All right, somebody choose a letter to try. P equals G. All right, let's see. X equals 21, 6. Oh, P, sorry. Okay, you know what? In the meantime, I'm just going to erase all the other stuff we have here. Yeah, P is 15, thanks. I was just reading it as G equals P, so that was my bad. 15 minus 11. So that's 21 times 6, which is 126. I think it's not G, right? Because if we do minus 130, then we get negative 4. And then if we do plus 26, we get 22. So I think it's W. But yeah, I can see why you might have gotten G, because minus 120 is kind of appealing, but 120 is not a multiple of 26, basically. Yeah. Okay, so I'll just put in W's for P's. Okay, it's kind of weird that something ends in W. Maybe oh, sorry. I think I forgot how to do math. Yeah, you're right. It's G. It's G. The mistake I made here is that 15 minus 11 does not go to 6. It goes to 4. So then that gives you 84. And then if you do minus 78, then you get 6. That's my bad. Z is I. One second. I'll check after I fill these in. What do you know about a word that ends in something something G, though? Like, what is it very likely going to end in? Especially if it's here, too. ING, yeah. So you can kind of just assume. And that does match up with what you're saying, that Z goes to I. Anything. Yeah, nice guess. Oh, whoop. I have to move the chat again. So now we just have a bunch of things to fill in because we got anything. So we can stop doing math for a little while and just fill the stuff in. Y is N. CULY is that. We have what Y equals. It's really similar to that, but it's not that, because we have all of these already defined from anything. So it's than. Yeah, yeah. Okay. You might be able to get this word off of just word patterns. Wow, I have to move the chat a lot during this one. Oops. These, there's a word similar to these. It's probably not these, because anything comes after it. And like, if you just imagine in your head, I don't think you can say a sentence like something these anything. Like, that obviously that wasn't very coherent, but yeah, I don't think it makes sense. Yeah, there, yeah. And then I think somebody mentioned is. How do you do the mod if the number is negative? Okay, yeah, I'll just put a random negative number here. So if you want to find the mod of negative 19, for example, dividing it by 26 and finding the remainder is the same thing as adding 26 here. Yeah, so it's 7. And if it's like negative 68 or something, a multiple of 26 is 78, because 26 times 3 is 78, so you can just do 10. Yeah, you're welcome. If you're not comfortable with just like thinking of multiples in your head like this, basically what you can do is in your calculator, you just do this as many times as you need in order for it to be positive. You know, if you are more comfortable with just like bashing it out instead. Is there anything? Yeah, it's a question, so is at the beginning makes sense. Is there anything I haven't filled in? Yeah, understanding. Nice. More. Yeah. Yeah, I think we have all of those letters already. And that should be pretty simple to see, right? Sympathetic, yeah. Nice job. All right, so the quote was, is there anything more dangerous than sympathetic understanding? Which, kind of a weird quote, but that's the quote. All right, so what does it mean? Good question. Some of the quotes are just from like really old people, you know, from like the 1300s or something, and they just say stuff to say stuff sometimes, you know? Like we can't possibly understand what they're trying to say. I think it means something like if people understand each other, like they can do anything or something like that. But obviously it's worded in a really weird way. Okay, so that if you remember to week 1, we talked about something called like, yeah, it's a positive quote. It's worded in a weird way because it's like a double negative because it's saying like it's dangerous, but like dangerous in a good way. Yeah, it's weird. But yeah, in week 1, we talked about how there's like cryptography, cryptology, and cryptanalysis. And I said cryptanalysis doesn't appear that often, but like with some math like affine and visionary and even railfence, it does appear. So basically what it means is that at least for affine, you're not given, oh, what did I just do? You're not given the a and b in y equals ax plus b. So they don't give you this or this in the question prompt. They just tell you like, for example, if I go on, they say it ends in SM. So I have this. They don't necessarily have to give you the last 2 letters. They just have to give you 2 letters at least from the entire thing. And okay, so what I'm about to show you is like a very crude way of solving it, but you make sure that you don't get anything wrong. So, okay, if you don't want to like put it in the public chat, I guess you could, if you just want to message me, like, have you learned about systems of equations or like how to solve them, anything like that? Okay, cool. So this should be pretty easy for you guys then. Yeah, ends in ism. That's also what I would guess because I'm pretty sure it can't end in any other vowel. Like there's no asm or ism, right? All right. Before I make that assumption though, I'm just going to show the systems of equations part. So we have the general equation y equals ax plus b. But if you think about it, we're decoding here. So everything in the top line, that's y. That's our ciphertext. So we have all the y values already. What we need to figure out are the x values because we're decoding. We want the plain text, so we want the x values. So we know y, and for these 2 letters at least, we know x. So instead of solving in terms of y and x, we can solve in terms of our unknowns a and b. So what that means is that if I look at this pair, f goes to m. Yeah, I think. I think that's what I'm doing. Yeah, so f is our y value. So f equals 5. So, and I'll just convert m equals 12. Our y value is 5. This equals a times our x value, which is 12, plus b. So a and b are our unknowns. And then if we do the same thing for this letter pair, j is 9 and s is 18. Be careful not to mix up y and x. Just remember that if you're decoding, y is what you're given, and then x is on the bottom. So we have 9 equals a times 18 plus b. And we always have to keep in mind that this is mod 26, because if it wasn't mod 26, it wouldn't make that much sense. Yeah, I think so. So here, what I like to do is elimination, because you're always going to have plus b and plus b. So if you just subtract the 2 equations from each other, I'll make it a little bit easier to see. I'll put the second equation above the first equation. And I'll also write the coefficient before the a instead of after. So essentially our two equations are 9 equals 18a plus b and 5 equals 12a plus b. So if we subtract, if we do elimination, we get rid of the b's, we have 4 equals 6a mod 26. Yeah, the reason I said we have to remember mod 26 is because 4 equals 6a doesn't make that much sense when it has to be an integer, right? It has to be an odd integer that's not 13. So there's a reason that we have to say mod 26. And what I'm about to show you here is not very methodical. It's not very scientific, but it will always get you the right answer. It's basically you keep adding 26 to 4 until you find a multiple of 6. Yeah, that's what I was going to do. Usually it's not that easy. Usually you have to add 26 like a couple of times to find a multiple, but what I was basically hinting at is that this is the same thing as 4 plus 26, which is 30 equals 6a mod 26. Yeah, usually you have to add like a lot of times to find an actual multiple, but this time luckily we only had to add once, so a is 5. Yeah, big brain. And then once we know that a is 5, we can just plug back in a equals, yeah, basically like this, then 5 equals, or actually you don't even need both. Yeah, I'm not going to do both. You just need to remember that this is mod 26. So 18 times 5 is 90. So 9 equals 90 plus b mod 26. I mean, there's a couple of different ways you can do this. You can just think of it as like, you know, adding 26 to 9 until you get the appropriate number again, but that's a little bit more complicated to do when it's like addition plus multiplication. So here I would just do move 90 to the other side, so like minus 90 minus 90. So then you get negative 81 equals b mod 26. And then, like I said before, like how to do negative numbers, just add 26, 26, 26, 26 until you get something that's positive and in between 0 and 25. Like obviously, it's a very crude way of doing things, but it gets the job done. So that would be the same thing as doing plus 104, and that gets us 23. So if I clean all of this up, our encryption equation is 5x plus 23. This is A, this is B. So we need to make this a decryption equation, which if we jog our memories, it's this. Yeah, I included the table at the bottom. So can somebody tell me what the inverse of A is? Yeah, 21. So we finally have our decryption equation. Now it doesn't matter the fact that we weren't given A or B. Like we can just do it now. There's no difference from where we are now to where we would be at the beginning of a regular decryption problem. So like that's the process of cryptanalysis. You start like disadvantaged and then I guess like you take back the advantage. Okay, so remember how I said we should substitute this number in for y first? X equals 23. So if we substitute, okay, I need to be careful about how I say things. X, the letter, maps to 23. So if we substitute in X, the letter, for Y, aka 23 for Y, then we get 0, and 0 times 21 is 0, which is A. And like Ethan said, it's like a decent assumption to say L is I. We could check if we wanted to, but like I don't think any other letter could go there. Okay, I think we filled in everything we have so far. I'm just going to show another negative number one so I can, you know, drill it in again. So if x equals 21 times y minus 23, say we want to do O just because it's at the beginning. Yeah, you're right about what that word is, Julie. Yeah, that word is right. I'm just gonna fill it in because once again, I don't think there could be another word, but like sometimes that just happens, right? Like you see it in your head, and that's a good thing. Okay, I won't fill those letters in yet though. So this is doing O. So 14 minus 23, so it's 21 times -9, which is -189. So if you want to add 26 to this like 9 times, wait, not, okay. Yeah, I think it's 9 times or 8 times. I mean, you can go ahead, but otherwise what I like to do is there are these like really nice multiples of 26 to think about. Because 260 is 26 times 10. That's like the easiest multiple to remember. 52 is easy because it's just 26 times 2. And then like 78 and 104 are times 3 and times 4. Those happen less, but what I like to do is I just add 260. Obviously, like that's not going to get me the right number because it's too big of a number to add to -129, but it's just easy to like navigate on your calculator. So you get 71 and then you do -52 to get 19. Like it's a roundabout way to do it, but it's just like how you limit mistakes. And it's just like you don't have to remember as many multiples in your head. If you just remember like 250, 26, 52, and then you only use those 3 numbers to do mods. Okay, so we have a lot of letters to fill in from finding narcissism. What could this word be? Actually, we did not have that many letters to fill in. Wait, what do you mean never mind? It's definitely there. Yeah, you were right. Wait, how come you backtrack though? Oh, all right, got it. Okay, so now that we have E, like that really helps. I do not know why I was about to put that there. This is an H. Have, yeah. This is kind of a common way to open a quote. It's something something. Yeah, those who, yeah. You can kind of see it based off of word patterns because like this portion is the same as this portion. Yeah, it happens a lot more than you would think. Am I missing something? I feel like I filled in everything that we've got. Oh, no, I haven't. Okay. Can you get this word? Yeah, love. Okay. You can probably just get this word, and then that should solve the rest of the thing. Or you can just guess what this letter is because it looks like it's past tense and it has have before it. Yeah. Part. Yeah, part would be right. And then that makes this P and then of. Yeah. So it says, those who love have pawned a part of their narcissism. Yeah, wholesome. All right. Yeah, I definitely think if we included Visionary today, we would not have had enough time since it's basically exactly 1 hour. So I guess like with the remaining time we have, I'll just go over like what's happening next or like what we'll do next. So if we take a look at the next slide, I mean, some of the homework just does not change, right? Because aristocrats are probably like the biggest part of Codebusters no matter what. This year, for some reason, like in Div C, they started having a lot more aristocrats. Like if I just give like a standard, usually like tests are 20 to 25 questions and it's shared between 3 people. I think Div B might be 2 people, but for Div C, it's 3 people. And like, that's a lot. And usually the top teams don't even finish the test, if it's written right, at least. But like, out of those 20 to 25 questions, I think like 5 or 6 of them were usually aristocrats in past years. And that's still like a decent chunk because there's a lot of ciphers, right? But now it's like 9 to 10 of them. Like they completely switched up. And the same people who are writing Div C tests now, like I've written a couple myself, like that trend is probably going to keep going when you guys compete in Div B. So like learning how to do aristocrats properly is really important. So puzzle barons or cryptograms.org, which is the same thing, is also really important. For what I post on Google Classroom, it's just going to be another JSON file to do through Tobes. This time, it's going to have mostly Affine though. So mostly Affine, I'll put like maybe like 2 aristocrats, 1 Caesar, 1 Apbash as a review. Besides cryptograms.org, I'd say letter number conversions is the most important thing, whether you want to do the Quizlet or just like, I guess even doing the Affine homework would help with letter number conversions because the more practice you get, the more automatic it's going to become. And then next lesson, it's going to be Vision Array, which kind of incorporates modular arithmetic. Yeah, it's basically easier than Affine because there's no like modular inverses or anything. It's just addition and subtraction and modular arithmetic. So like adding and subtracting 26 to places. All right, so